All right, folks, let's look at how to balance a redox reaction under acidic conditions. So let me get to the pen and let's see, what color is this? Let's go with magenta for right now. We'll change it over later. So when we're doing writing a redox reaction, we're going to do this. Some of this we already talked about in the previous slide video. First, we write the reaction down. This will be given to you, but for the most part, and it won't be complete. There'll be things missing, and that's what you're going to be putting in. We're going to assign oxidation numbers, figure out what's being oxidized and what's being reduced. And that's where this comes in. Then we split the reaction in two. Then we're going to add electrons needed to undergo the oxidation reduction. You have to add the electrons because we're following the electrons as they flow in this reaction. Then we balance the elements, heaviest first, oxygen, hydrogen last. And part of this is going to work with this as well. These two probably end up going hand in hand because sometimes to balance the electrons you need to balance the element that's being oxidized or reduced. So they kind of go hand in hand. Sometimes you can do one first, number 5 first, and then number 6, or 6 first and then number 5. It depends just how it looks. And then balance, after you get everything balanced, or the elements balanced between the two half reactions, then you're going to have to balance the number of electrons in between. And before we do that on this, to balance hydrogen and oxygen, we're going to add water. Add H2O for oxygen and H plus for hydrogen. So we're doing something different from what we did last year. So when we're balancing the elements, when we have the heaviest first and these two are last, more likely than not, you're going to end up adding water in because all these occur in solution. So water is our solvent. We're going to add the solvent into the reaction as a source of oxygen and as a source of hydrogens. And then since we know that hydrogen can split off, we add H plus for hydrogen, and that will give us some extra stuff into our reaction. And it's going to come out correctly. And we'll see that in this example. And then once we balance the electron between the two, we're going to multiply one of these half reactions by a factor to get the electrons balanced. We combine. If we have things on either side, x and x, we can cancel those out, and we don't have to put them into the reaction. If we want a basic solution, we're going to have to add hydroxide to both sides. And then we're actually, where the protons are, we're going to form water, and we have OH on the negative side. On the other side. This is a little complex, but with practice you can do this. So let's look at this reaction. Chlorate anion plus sulfur dioxide. When they react in solution, you're going to get sulfate anion and chlorine and chloride. So we're going to assign oxidation numbers. So we've got the reactions, so assign oxidation numbers. And this is how I abbreviate oxidation numbers. Excuse me, oxidation numbers. I've been doing this too long. All right, chlorine. This is an easy one. Cl and minus. This is -1. The element with a charge on it is going to be -1. The charge on it, so this is -1. All the oxygen in here are bound to the central atom, or the other element. And so oxygen is going to be -2. So this is -2. This is -2. This is -2. Now, what we have left is this chlorine and these two sulfurs. So let's look at ClO3 minus. Total charge is -1. We know oxygen is -2. What is chlorine? We don't know that. So X plus 2 times a -2, excuse me, 3 times -2 is going to equal -1. So -2 times 3 is a -6. So what we don't know, this chlorine, this oxidation number plus 6 should equal -1. So what is X? If you do the math, X is equal to 5. So that's the oxidation number of this chlorine is 5. And so that leaves this sulfur and this sulfur. For SO2, it's neutral, so wherever this is going to equal 0. We don't know sulfur, but 2 times -2 is our oxygen. That's going to be -4. X minus 4 is equal to 0, or X is equal to 4. So this oxidation number is 4. So what's this guy? So move over here, SO4, that has a total charge of -2, or -2. X plus 4 times -2 equals -2. That's going to be -8. Or X is equal to 6 if we do the math. So this oxidation number is 6. So between these two, we're losing two electrons. Here, so this is so sulfur is undergoing oxidation. Chlorine is going to be reduced because it's gaining electrons, and the number of electrons it's gaining is 6. It's going from +5 to -1 for a total of 6 electrons gaining. There we go. So next slide. So if we come up here, we got ClO3 minus plus SO2 yields SO4 minus plus Cl. You notice in this reaction, we don't know how many oxygens we have. The charges are not balanced between left and right hand side, so we do know that electrons are being transferred. So let's look at what is undergoing oxidation. So oxidation, OX reaction, is going to be just the sulfur going to SO4 minus plus so many electrons per sulfur. Come up here, as it's going from as each sulfur is going from 4 to +6, it's losing 2 electrons. So we have 2 electrons on the right hand side, indicating that the sulfur is losing the 2. So we can do the reduction reaction, or we can go ahead and balance the oxidation reaction. It doesn't matter which way you do this, folks. It's up to you. But let's go ahead for the reduction. That means ClO3 is gaining some electron. We said 6 electrons, and that is going to Cl minus. And I forgot to put the negative sign up here. Where am I? There it is. Ding. This just looks somewhat easy, but it could be deceptive. So next, for the oxidation reaction, balance the 2 sulfurs. That balance S and O. We got 1 on sulfur on each side. On the left, we got 2 oxygens. On the right, we have 4. So we're going to have to add a source of oxygen to the left-hand side. This is different from what you learned last time. And to do this, we add 2 molecules of H2O. So that changes to 4. Then we're going to end up with 4 atoms of hydrogen. Do that, we're adding 4H plus on this side. And I'm going to rewrite the equation starting here as 2H2O plus SO2 yields SO4 minus plus 2 electrons plus 4H plus. Now, as you're looking at this, there's a couple ways to look at this and say, I got this right. One, if you look at the charges on the left, both of these are neutral molecules. Now I should have a neutral charges should equal, should add to 0 on the right. Nah, I can't talk. So -2, -3, -4, plus 4, that means 0. That means I'm fairly confident that this is correct. For now, for my reduction. I got 1 and 1. So that looks easy. Now on the left-hand side, I got 3 oxygens. So I need 3 oxygens on the right. To do that, I add 3 H2O. So that's 3 oxygens. Now I add 6 hydrogens onto the right. So I need 6 on the left. So that's 6H plus to balance that, to get that all the elements balanced. And to rewrite this, I get 6H plus ClO3 minus plus 6 electrons. And that's going to give me Cl minus plus 3 H2O. Let me check something. Yes, I got enough room. So what I'm going to do is rewrite these 2 half reactions on the next slide, and we'll show them how to add these. So again, I'm just going to rewrite this as 2H2O plus SO2, and I'm going to end up yielding, let's see, SO4 2 minus plus what did I say, 2 electrons plus 4H plus, and down here we got 6H plus ClO3 minus plus 6 electrons yields Cl minus plus 3 H2O. And the charge is balanced and everything's fine. Now, before we add these 2 together, we need to have the electrons on this redox and on the reduction and oxidation reactions the same. In the reduction, we got 6 electrons. Up here, we just have 2. So we need to multiply the whole equation by 3. So 2 times that's 6 H2O plus 3 SO2 yields 3 SO4 2 minus plus 6 electrons plus 12 H plus. Now I'm going to take my advantage and come down here and change the pen to a different color. Come on, I want red. So as we come up here, if I had the same molecule on each side of the arrow, I can cross it off. Well, look, 6 electrons on the left, right here. 6 electrons on the right. I can cancel those out. I have 12 protons on the top here, 6 on the bottom, separate sides of the arrow. These 6 eliminated, and then this becomes 6H plus. See how that works? I only can eliminate as many as I have on both sides. If I have extra, that leaves no extra up here. 3H2O on the bottom, that becomes 3. And now I can add, I think that's it. So I can add these together. So 3H2O plus 3 SO2 plus, now we add our Cl3 minus, that's the chlorate anion. Now we go into 3 SO4 2 minus plus 6H plus Cl minus, and that should be a balanced reaction. And that's it. And it's under, since we're having acid produce, H plus, this is what we call an acidic solution. The acidic solution is acid on either side, either the left or the right hand side, it doesn't matter. If we would have this under basic solution, this would look a little bit different. Now, if you have any questions, please let me know, and this is the end of the lecture.